we are a distributed team. Joshua and I started together in Canberra, but now I'm currently in Adelaide, and Gisheni is in Nairobi. So we are in all different time zones. So yeah, this is a story of BlenderNC software journey. I put together the slides, and Joshua added some nice videos to it. So I think there will be some visualization content here. So the question is, how do we visually communicate climate and weather simulation data? You can create nice realistic views of what the Earth looks like at different times and show the dynamics of it, create what we would call a digital twin of the Earth, and show it to people, and people can get this, what astronauts normally get, the overview effect of seeing the Earth live and changing, and appreciate the planet. So the project has seen a lot of work from Australia recently, and I have contributed little bits and pieces of guidance and suggestions, and I guess making slides and writing issues on things to do. Gisheni is looking forward to adding some forecast data into it. So BlenderNC produces visualizations like that, the one you saw. And we have a couple of bigger ones here to show. And this one is showing some temperature visualizations with cloud heights included. And normally in a package like Magix or Matplotlib, it would be a flat visualization like this, and you can animate that to a PNG. If you want to display it in a global context, you will have to overlay this on the globe. And BlenderNC does that using Blender's 3D rendering engine to actually use a UV sphere and use displacement and textures and bump maps to give you a much more realistic and rendered view of all the data that's available. So here that there is a transparent sphere outside with the clouds with displacements according to height, and then an internal one mapped to the temperatures. We have another one. This one is showing ice and salinity, and you can see the dynamism of it and variations. Things disappearing and reappearing seasonally, and then internal microstructures and movements. Shui is an oceanographer, so a lot of the visualizations that he previously built are based around oceanography. I am more an Earth observation person. I work for Geoscience Australia, which is an Australian Earth observation agency. I will share the story of how we came to find each other and work on this together in a minute. So yeah, so that's the story of how we came to start this project. It's this presentation you will find is slightly less technical than the other presentations, and has I'm an engineering manager, so has a more storytelling aspects to it. So I followed ECMWF on Twitter, and due to other work I was doing around live observation of rainfall in Africa, and I found I was consuming ECMWF forecast data at the time to compare our rainfall captured and the actual forecast. I found the project when the ECMWC was announced, and I was rooting around in the BlenderNC source code. So it specifically said we would like to enhance BlenderNC. And I found that references to Gaudi, which is a supercomputer here in Canberra, not here in Canberra, was in Canberra at the National Compute Infrastructure, and realized Joshua was in Canberra. So I caught up with him, and Gisheni was collaborating with me from Nairobi on the weather observation system. So brought him along he had actually subscribed to ECMWF forecast data feed to look at the weather data, and I wanted to have that visualized in BlenderNC as well. So yeah, to support the grid format we were receiving the data in. So yeah, I just put a proposal together, and the proposal essentially addressed what the task was, to improve the documentation of BlenderNC, improve all of our coding practices, continuous integration, continuous delivery pipelines, for ECMWF specific purposes, add support for the grid format, and also create some of these interesting animations using the forecast and reanalysis data that is available in grid format, and possibly in the future, as other presenters were saying, in ZAR and other formats as well. So previous to this work, BlenderNC, as the name suggests, only supported NC or NetCDF files. So now we have support for GRIB and ZAR once the huge PR that Joshua is working on lands. Yeah, so we have added many features as we have improved. So the progress so this is another visualization of like a digital twin aspect. So the progress has been huge. If you look at the number of commits in the development branch, the amount of features and small fixes and big fixes have been added are huge. So you can, using the ECMWF data, reanalysis data, create digital twins of how things actually were at a time in the past, which is very impressive. Sometimes think of the weather simulation stuff as having sort of a time machine, looking forward and looking back and seeing what the Earth is like. So one of the tasks was to improve the BlenderNC documentation. This is the BlenderNC documentation page, hosted in Read the Docs. It consumes a GitHub repository and puts up the documentation. So we have added new screenshots, and there is a bit more work to be done. So the BlenderNC documentation goals were to make it easier to adopt BlenderNC to visualize your data. You would not default to using standard plotting packages or using an off-the-shelf tool. So you would have to have good instructions in installing this on top of Blender through the available locations, available repositories, the Git repository or the Python package repository, because BlenderNC is a Python package. Provide the simple possible working examples and provide the data and add-on usage instructions. So we have a small XKCD illustration here because a tool which has no documentation, or the documentation needs the documentation, creates problems. So ideally, the interface is good enough that you solve the problem at hand without having to read the documentation. It's intuitive. Blender is a quite difficult to use tool for doing 3D graphics, and adding more difficulty using on top of BlenderNC will put us in a worse position. So we are sort of in a tool that needs a manual stage once you are familiar enough with Blender. So there are still more work to be done for the examples to be created, the simple animations, adding the sphere, loading your files, and a lot of the 3D animation creation, especially in Blender, is an artistic exercise as opposed to as well as a scientific exercise. So how you want to do your storytelling and moving around and your camera views and the amount of, what would I best say, drama you want to add in your story, in the visual story, is important. We also are looking at the coding practices in BlenderNC, so the CI/CD pipeline. So there was when I started looking at it, it was a mix of GitHub Actions and Travis, and there was not a lot of code coverage applied, which I'm really passionate about. And Sylvie mentioned some concerns around support for different versions of Blender. So we ended up working a lot on the BlenderNC CI/CD pipeline. to add a lot of GitHub Actions to perform the builds, publish to PyP, and a lot of them. So you can see the specific improvements here. So we added continuous testing, continuous integration using Docker container, which Blender Docker container is actually published by the New York Times. So I guess New York Times uses Blender for some of their visualization work as well. So migrated the CI pipeline to GitHub Actions completely, consistent code styling, implemented coverage testing. Previously, there was no coverage testing. So different version supports for different versions of Blender using GitHub matrices tests, which basically you can say test different versions. And as long as the New York Times Docker image exists for it, you can test against that Blender version. And also to ease installation, you can publish the packages into PyP. So someone in Blender can pip install BlenderNC to get that on. So we automated a lot of our testing so that we could ship new features. So once you have automated it, you get more free time, or you can do more work out of it once you have removed any doubts around, will this really work? Otherwise, things get, as everything you add, you break 3 different things. So these are the different workflows in GitHub Actions that have been added. I really like the one that Joshua has added, where it uses the pre-commit to automatically fix your code. It makes the code commit on top. So I'll always forget to run pre-commit or install the pre-commit for a new repository, and it breaks on CI. So if the CI can fix my code, then that reduces a lot of work upfront. So we had very low coverage or no coverage. There was no measurement of the coverage, but now we have almost 70% coverage of the tests on the BlenderNC Python code base. Some of the visual testing, because Blender is a graphic tool, is difficult because we are testing in a headless mode in the continuous integration pipeline, but well, things will get better as we add more unit tests. Yeah, so presentation is relatively short. In conclusion, we have done a lot of work in improving how the BlenderNC code can be done. We have started supporting the grid format. Now it's more fun part of actually utilizing it and creating some interesting animations using some data we get. Possibly improving reading of the data through ZAR or whatever new partitioning things we find that will let Blender read the data. Attempting to read very large data sets into Blender will be difficult. So we may need to look at some of those things to allow scalability of the rendering and multi-scale rendering possibly, as well as some of the headless rendering aspects of it for producing similar stories on a regular basis.